Hello everybody, welcome to watch again our video course on Ruff IoT application development. After learning the previous 4 chapters, I guess you must have had a general idea about Ruff development. Previous 4 chapters mainly focus on hardware control, networking operating, and IoT cloud. These 3 parts and introductions were made on some links of Ruff application development. That you should know. Next, I'll introduce to you more advanced development knowledge, namely Ruff driver development. This video course will focus on the application level development of Ruff, so app development is a key part of this video course, while the introduction to driver development is not. So in this chapter, we only introduce some basic knowledge of Ruff driver development. When you're developing apps, hope you guys can learn a little about driver development. Alright, first, let's look at the development layers that Ruff opens to its developers. You mainly open 3 layers to developers, namely app development, driver development, and board development. The 3 layers are from easy to difficult, and also from a higher layer to lower layer. Let's first look at app development. App development is actually the simplest one. Developers should also learn about it. A developer, as a minimum, only needs to know some basic knowledge on software programming and can do app development. Let's look at the level of app development. It is at the highest layer of all development. Without knowledge of some operating mechanisms of bottom layers, such as Ruff board, Ruff OS, and Ruff drivers at the bottom layer, it does not require specific operating principles. It only requires the acquisition of modules and APIs that Ruff OS exposes to developers, and modules and APIs that drivers expose to developers. With the above 2 parts alone, Ruff app development becomes feasible. Next, let's look at Ruff driver development. Ruff driver development actually exists between Ruff apps and Ruff OS. It requires the mastery of the hardware interfaces that Ruff OS exposes to driver developers, and the APIs of these interfaces, as well as some operational logics of devices. These APIs and logics are adopted to write the entire device driver, and it generates a code file and document of driver, provided to the app developer. The app developer reads this document and API to actually operate this device. Then, let's move to board development. Board development requires developers to have thorough knowledge of hardware. He needs to expose to the OS the resources the board has and the characteristics of these resources. Next, let's have a look at the main steps of Ruff driver development. The steps can be mainly divided into 2 parts, namely adding the device and driver development. For the details, I'll give you a demo in part 3 here about how to develop a driver from scratch. So steps are only theoretically explained here. So you guys only need to master basic principles. First, add the device. Let's look at the steps details. To start with, log into our Ruff Registry, an official website of the software repository, and then register an account. Next, let's enter the page for adding a new device and fill in some basic information about the device, such as the device name and model. Next, we should create the interface layout and upload a picture of the device. Add the external interface of this device in the picture. Then we should fill in some detailed information of the device. Say, its external interface, its specification, and its mode of power supply. In such a way, when other developers are using our device, they can learn about some detailed information of this device. Next, we need to bind the driver. And let's skip this step for the time being, as we haven't developed this driver yet. Okay, the second part is to develop a driver module, and it requires us to download the Ruff SDK, as we need Ruff tools throughout driver development. Let's look at its detailed steps. To start with, let's create a new project of wrap driver. We can use wrap init driver, such a command to create a project, and then fill in some basic information, like its version number, its author, and so on. We might as well just skip it now and fill it in at the end of our operation. Then, next, after we finish the operation of wrap init driver, a basic directory will be created for us, and this directory includes some basic files, mainly 3 files, namely driver.json, package.json, and srs/index.json. In driver.json, we need to add the hardware interface needed for this device, including its type, quantity, and some necessary characteristics. Next, we need to refer to the datasheet or manual of this device. Then, write the code logic according to the corresponding logic. Next, we need to improve the basic information of driver, including its homepage, address, and the repository for code maintenance address. Next, we'll write its external driver document. This driver document is mainly for users to read, and users may read this driver document to learn the features and functions included in the device driver and how to use their APIs, etc. And when we enter wrap add user to add a wrap registry account. After adding it, we may run such a command, wrap publish, to publish our driver to registry. After successful publishing, it is automatically bound to this device, as both the device and this driver have a unique model identifier, respectively. This model can be used to bind the two. It automatically completes the step of binding the device with the driver. It's worth mentioning that the so-called device interface here is not an API of software level, but an interface of this device hardware. As I mentioned just now, after we execute this command through wrap driver, it generates some default files for us. Next, I'll choose 2 to elaborate. Since we mainly deal with 2 files, when we write drivers, the 2 are driver.json and src/index.json. Let's first look at this file of driver.json for drivers. This file serves to describe the information on the hardware interface of device, and this information consists of the following major parts, namely the type of this interface. Say, our wrap provides externally some hardware interfaces, some abstract APIs. For example, our interface types include GPIO, I2C, and so on. As to the quantity, it is mainly embodied through the way of key-value pair. Say, here, if the device has only one interface, we just use a key value, such a pair to represent it. If there are 2 interfaces, we need 2 keys to represent. Next is the initial value. For example, when our hardware interface is initiated, what's its initial status? And when we apply for GPIO interface, after its initiation, does this GPIO interface output externally a high level or a low level? That's a status describing the interface after its initiation. Next is the characteristic of this interface, and this is a new feature of our new Ruff version. Say, this characteristic describes an ability of hardware interface and some capacities of an interface we need to apply for. And when we apply for a GPIO interface, do we need the reading or writing capacity of this GPIO? We may fill them in the field of features. Now, src/index.js file of the driver. Its effect is to realize some logics for specific execution of device. And when we write the entire file, our Ruff provides a driver framework, i.e., a Ruff driver package. And this framework provides driver developers with some supporting mechanisms to facilitate driver developers' development. And this package contains 2 main fields, quite important. One is attach, which equals device initiation. After device initiation, the device enters the callback corresponding to attach. And in this callback, we may acquire the object of this interface. For example, let's look at this example. When this driver has been initialized, it enters the callback function of attach. In this callback function, we get the interface object of GPIO. Next, let's have a look. The next important field is exports. It serves to define some APIs in it. And then these APIs may be exposed, and app developers may use these APIs to operate this device. As to specific API type, we're going to define. We need to design it according to the manual of this device. And in this API, we may adopt the interface object acquired above to operate this device. Here's an example. For this device, we mainly expose externally 2 functions. One is turn on, and the other one is turn off. For turn on, we need to call the writing capacity of GPIO to write a high level to it. And for turn off, we need to call the writing capacity of GPIO to write a low level to this GPIO. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much. Ruff, make IoT easier.